John sent us a message, Eureka.
Yeah, Eureka.
So some areas for improvement. We initially had an idea of using the key circuit through the USB connection, which is already powered by USB, to receive through the pushing of the button to switch between modulation and demodulation. So this would require very minimal use of the user and software. So just pushing the button automatically switch to modulation, and the default is set to demodulation. However, we did run into some issues. Due to the microprocessor we're using hardware constraints, we're not able to actually implement the function. The key circuit that the microprocessor we're using does not implement a USB peripheral. Another issue we developed is time limitations. We would have to require to build a function that calls USB stack and require a lot greater processing than we would be able to complete in our time, so we decided to not implement this feature. And we were also unable to test the feature because we were doing one-way communication. Another issue that we could have continued on was phase detection and correction. Usually phase detection, loop delay is not an issue. However, if the incoming signal is delayed enough so that it is completely out of phase with the local oscillator, you will hear nothing. The signal strength will be minimized. However, if it is completely in phase, then the signal strength is maximized. But usually the transmission is somewhere in between these two P's. So that is why the demodulation is possible. However, if we're able to keep this function as close as possible in phase, we would be boosting the signal strength by keeping it as maximum as possible, and hence raising the signal out of the noise floor. I developed some code to initially try to do this. However, like Tom mentioned before, converting the MATLAB code to C code and integrating it into our C function that we had written proved to be too numerous in errors and lots of bugs to be fixed due to the Linux errors and paths and other various bugs like that. Do you have any questions?
All right, I got two quick questions. One is, if this is for the U.S. Navy, did they require you to have any sort of security measures? Because potentially, if you have multiple subs using this communication system and someone's listening in and they figure out how to demodulate your signal, they can also listen in.
Right.
That's the first question. The second question is, did you guys consider doing any sort of cleaning on the noise when you're doing the demodulation to filter out anything that's sort of making it more difficult to hear due to anomalies in the water or natural sounds?
Okay, well, I can answer the first question. We spoke with our customer, and we're actually not building a full end-to-end system.
Okay.
So they already have hydrophones, amplifiers, and transducers and amplifiers on their side. They just want the software module, the key circuit, to basically integrate into their system as it is right now. And this, as Scott mentioned earlier, that this system is not for secure transmissions. They already have a special dedicated way to do that. This is more for daily communications, unsecured communications, like going from arranging ships, say, in a yard, or to just daily communications such as has mail arrived yet, stuff like that. So it's just daily, day-to-day unsecured communications.
There are filters in the code. So, however, to keep the real-timeness of it all, the number of coefficients matters. So for the low-pass filter, it's a fifth order. For the band-pass filter, it's a seventh order filter. And both on demodulation and on modulation, both of those are applied. So on modulation, it's a low-pass filter, so only the voice is modulated. Right. And then a band-pass is the upper sideband. And then on demodulation, it's upper sideband, demodulated, and then low-pass filter.
Yes.
A couple of questions. What's the bandwidth of your transducer?
I believe that it goes much higher than we're using it for. So we're going up to 8,300, 8,000 or 9,300.
Roughly 8 to 12 kilohertz.
I think the transducer itself can go up to like 30,000.
And what kind of transducer is it?
Is the ITC?
Not the numbers.
Okay.
Physically, how does it work? Is it a piezoelectric? Is it a magnetic coil? Is it a gnome with a hammer inside the transducer? What is it?
Yeah, Well, basically, I think it's electric to acoustic. We haven't actually cut it open to actually see what's inside, but it basically just picks up vibrations from the
What
water.
kind of signal do you feed it? How
Electrical.
big is the voltage and how much current does it take?
Okay, so basically, you feed it analog signal, the same signal that's coming out of the sound card. Obviously, it's amplified. So, and depending on the amplifying power, depending how long you want to transmit the signal, you'll send it a higher voltage or a lower voltage.
Do you know what the input impedance of the transducer is? That's okay. And one more question. Why do you need all this stuff? Why don't you just use sonar like they use in the movies? Why do you need all this sophisticated stuff if it's insecure, if it's not secure communication?
That's what was given to us.
The reason they already have their system set up this way, and they want us to create a cost-effective software solution to fit into their current equipment they have.
Fair enough. Okay, thanks a lot. Good project.
You tested it in 1 foot of water. Is there anything that you gained in putting it down to the pool and testing 50 feet of water or something like that?
Actually, I think we tried to rent the big Olympic-sized pool that we had at Deligianides, but I think we were unsuccessful in doing that. Plus, also, we thought about testing it by Charles, and it's just way too much equipment. We would have to take two PCs and the transducer and the hydrophone are pretty simple to take, but the amplifier is pretty big, and then the power supply and everything.
And our customer also mentioned when he gave us the amplifiers that they're not really good amplifiers, just for testing purposes. We might not even have the range to go that far. Yes.
Like, were disturbances in the water affected in any way? Like different sea states, like sea state 1, 2, 3, how would that affect your system overall?
Well, definitely vibrations in the water affect it. You can actually, if in our testing hub, if somebody walked heavily around the hub, you could actually hear the banging sound. So you would hear that plus the signal that you're trying to get. So, but actual boats and vibrations in the water. So if somebody's like messing around with the water, that did not affect it as much. So it was basically, if you're on a river, somebody's driving by on a highway that's close enough, that might affect vibrations a little bit more than a boat going over the water.
And the other thing is these are designed for deep sea communications, and there's almost no surface to reflect off of. So even if you go to Charles River, for example, there'll still be two signals bouncing off the top of the water or on the side of the Charles that would cause enough reflection. Still be noise. We're never going to get the perfect testing tools.
I think at the end, somewhere in the talk, I heard you say that the oscillator at the receiver end had to be in phase with the one at the transmitter.
Right.
And so I think you're doing synchronous demodulation. The oscillators have to be synchronized.
Yep. Well, this is an area for improvement.
No, but did you consider asynchronous methods to begin with that is peak protection?
They're not
No,
the same.
sorry. Yeah, they're not sync. They are asynchronous. This is for further area to improve detection making. Because usually, if the two oscillators are out of phase,
Yeah.
this code would correct that and put them in phase. This is just for syncing issues that might arise if you're two-way communication. You only do one-way communication with one hydrophone, one transducer.
Next, I'd like to bring up Team 10 of Optical Night